Hello, this is Mrs. Decker, and this lesson is on Objective 2A and 2B, Limiting Reactants. 2A is explaining what a limiting reactant is and the role it plays in chemical reactions. And then 2B is using stoichiometry calculations to determine which reactant is the limiting reactant. So the limiting reactant in a chemical reaction is the reactant that's going to limit the total amount of product that can be formed, because the reaction will stop when all of the limiting reactant is consumed. So there will be no more of the limiting reactant left when the reaction is done. The excess reactant is the reactant that's going to remain when the reaction stops because the limiting reactant is completely consumed. So the excess reactant remains because there's no more of the limiting reactant to react with it. So the reaction has to stop. All right, so if we look at this in terms of cars, if we have 8 car bodies and 48 tires, we want to figure out how many total cars we can make and what our limiting reactant is. So for each car, you need 1 of the car bodies and you need 4 tires to make a total car. With 48 tires, you could make a total of 12 cars, while with 8 car bodies, you can only make 8 cars. So once the car bodies are used up, the reaction of making a car is going to stop. So we'll get 8 complete cars, and we'll have 16 tires left over. Example problem number 1 says a 2-gram sample of ammonia is mixed with 4 grams of oxygen. Which is the limiting reactant and how many moles of product will be made? So we're given the masses of both reactants, and there are 3 questions that we need to answer. Which is the limiting reactant, NH3 or O2? What is the excess reactant, NH3 or O2? And how many moles of NO will be produced? So for this problem, we're going to do 2 stoichiometry calculations, one starting at 2 grams of ammonia and then going to moles of NO, the other starting at 4 grams of oxygen and going to moles of NO. Now, if it doesn't specifically ask you to find moles of a certain product, you can go to either product as long as you use the same product for both calculations. So if the problem is just asking you to figure out which is the limiting reactant, you can use either NO or H2O. But since question C asks for how many moles of NO specifically, we want to have our product that we go to be NO. So we're going to start with 2 grams of NH3, and we want to convert that to moles of NO. So we're first going to go to moles of NH3, and to do that, we're going to use the molar mass of NH3. Okay, and now that we're at moles of NH3, we want to go to moles of NO using the mole ratio from the equation. So for every 4 moles of NH3, we have 4 moles of NO. So when you calculate that, you will get 0.118 moles of NO. So that's our first calculation. Our second calculation is going to start with the 4 grams of O2. So again, we want to go from grams of O2 to moles of O2 using the molar mass. And then the mole ratio to get from moles of O2 to moles of NO. So when you calculate that, you get 0.100 moles of NO. Now the limiting reactant is the reactant that's going to stop the reaction because it's going to be used up. The limiting reactant is going to produce the lesser amount of product. So that would be this 0.100 moles of NO. So question A says, what is the limiting reactant? The limiting reactant is the reactant that produces this lower amount of product, which is O2. So our limiting reactant is O2. B says what is the excess reactant. If O2 is the limiting reactant, then NH3 is our excess reactant. And then C says how many moles of NO are going to be produced. So it's going to be 0.100 moles of NO produced. Example number 2 says a reaction container holds 5.77 grams of P4 and 5.77 grams of O2. And here is our equation for that reaction. Again, we want to know what the limiting reactant, what the excess reactant is, and how many moles of P4O6 are going to be produced. So we're going to start with 5.77 grams of P4 and convert that to moles. And then we want to go from moles of P4, which in the equation there is 1 mole of P4, to moles of P4O6, and there is 1 mole of P4O6 in the equation. So when you calculate that, you get 0.0466 moles of P4O6. Our second calculation is starting with 5.77 grams of O2 and convert to moles of O2. And then convert moles of O2 to moles of P4O6. So from the equation, there are 3 moles of O2 to every 1 mole of P4O6. So when you calculate that, you get 0.0601 moles of P4O6. So now remember, the limiting reactant is the one that is going to produce the lesser amount of product. So this is our lesser amount of product. So our limiting reactant is P4. Our excess reactant is O2. And the amount of P4O6 produced is 0.0466 moles of P4O6. Example problem number 3 says 4.95 grams of ethylene are combusted with 3.25 grams of oxygen, and here's our balanced equation. Same 3 problems again. We want to find out what the limiting reactant is, what the excess reactant, and how many moles of CO2 will be produced. So we're going to do one calculation from 4.95 grams of ethylene to moles of O2. And our second calculation is going to be from 3.25 grams of oxygen to moles of O2. So convert grams of ethylene to moles. The molar mass is 28.02 grams. And then we're going to use the mole ratio to go from moles of C2H4 to moles of CO2. So there's 1 mole of C2H4 for every 2 moles of CO2. So when you calculate, you get 0.353 moles of CO2. And then 3.25 grams of oxygen, convert to moles. And then the molar mass from moles of oxygen to moles of CO2. So there are 3 moles of oxygen for every 2 moles of CO2. So that gives you 0.0678 moles of CO2. So the limiting reactant is the reactant that produces the least amount of product. So in that case, that would be O2. The excess reactant is C2H4, and the amount of CO2 produced is 0.0678 moles of CO2. So the next page of your packet has some practice problems. Go ahead and work on those, and let me know if you need help.